Hi, welcome to Spark Study. This lecture is all about the extension of sleep power recovery system. And the second part of the sleep power recovery system is nothing but the Scribbler system. So earlier we have studied about the Kramer system, and this lecture will study about the Scribbler system. There will be a small difference between the Kramer system and the Scribbler system. Both system is applicable to slip ring induction motor. If the armature winding of an induction motor can be brought out to connect external resistance, that type of induction motor is called a slip ring induction motor. In the Kramer system, we recover the wasted slip power and feed back through a series of machinery, and the output of the series of machinery is fed again to the induction motor as mechanical power. That means here mechanical power is the feedback. In Scribbler system, feedback will be the electrical power. Right? That means the power which is wasted in the slip ring resistance, we collect those power and feedback to the series of machinery, and the output of the machinery for Kramer system is the mechanical power, and output of the machinery of Scribbler system is the electrical power. Let us draw the circuit diagram for Scribbler system. In the Scribbler system, anyhow, we'll have a slip ring induction motor as usual. The shaft of slip ring induction motor is connected to a mechanical load. Right? So this will be the shaft. Okay. And to operate the slip ring induction motor, we need a three-phase supply, which is available from the bus bar. Right? So this will be my R, this is Y, this is B, and we connect each phase to the induction motor. Now my induction motor is getting supply, and the armature of slip ring induction motor is connected to a slip ring. What we do, we take a rotary converter, and the three-phase power from the slip ring will be connected to the rotary converter. And the output of the rotary converter is nothing but a DC power. This is my split ring, so we'll have a positive and negative DC power, and that DC power is again used to drive a DC motor. Right? And the DC motor shaft is again connected to an induction generator. So the output of induction generator is three-phase AC power, which is again feedback to the main supply bus bar. Clear? Here the DC machine excitation can be changed by an external resistance or external DC source. So you can see here slip ring induction motor is actually driving this mechanical load, taking supply from this three-phase bus bar. And by speed control means when we want to control the speed using armature control method, some power is wasted in the slip rings, and we collect those slip power and feed back into the rotary converter. Rotary converter is used to convert three-phase AC into DC power, and that DC power again drives to a DC motor, and that DC motor mechanical output driving a induction generator, and the induction generator output is a three-phase AC power. So by varying the excitation, we can change the speed of DC motor, and by virtue of which the speed of induction motor also changes, and will get different value of AC power in the feedback line. Here you can see the slip power, we collected it and passed it through circuitry or machinery, and then feedback as electrical power. So this is the system which is called Scherbius system, and this is nothing but the conventional Scherbius system. This is called conventional as because we are not using any solid state device. Here all the converting part, collecting part, everything will depend upon the machine. That is why this is called conventional Scherbius system. Let us study about the static Scherbius system. So the circuit arrangement in front of you is nothing but the static version of Scherbius system, or you can say it is static Scherbius system. So here we have three-phase power. So here we have three-phase power supply, that is R, Y and V, and this three-phase power supply is used to drive the slip ring induction motor. And the output mechanical power of slip ring induction motor is used to drive the mechanical load. Here the slip power of the slip ring induction motor can be collected from the slip rings and fed back into a control rectifier. So this is nothing but the three-phase control rectifier. And the rectified output, that is the DC output, is again passes through an inductor which is used as a filter circuit. So the AC ripple is wiped out in the inductor. That means the output of the inductor will get steady DC. Here we are getting pulsating DC. So after that, when the steady DC is fed back into a control inverter or three-phase control inverter, right? And the output of three-phase control inverter is three-phase AC, which again given into the primary of a transformer, and the output of transformer or the secondary of transformer is connected to the power supply, that is RYB. Here the power which is actually wasted in the slip by varying the speed, that is collected by the slip ring and given into a three-phase rectifier. And the rectifier is converted AC into DC and passes through a filter which actually rectifies the harmonics, or which is rectify the AC ripple. And the ripple free DC again given into a three-phase control inverter which is actually converting DC into AC, and that AC is stepped up or stepped down according to the requirement is fed back into the supply using a transformer. So this is all about the static Scherbius system. Here you can see the power which is wasted in the slip ring is fed back into the supply, that is electrical supply. And we can say the power flow is from a rectifier to inverter side. That means from slip ring to the transformer. That means first the power is slip power. Slip power is given to a three-phase control rectifier, and three-phase control rectifier output given to a filter, and the output of filter is given to three-phase control inverter, and the output of three-phase control inverter is given to a transformer, and then again it feedback to the supply. So here you can see, as we are taking power from the slip ring so that we can get the speed below the synchronous speed. To get above synchronous speed, what we did, we take power from the supply, and the power flow is not from left to right. Here power flow is from right to left. So it is clear that whenever we are taking power from slip ring and given back to the supply, then it is work as a under synchronous speed. And when we take power here from here, and then three-phase power converted to DC, and the DC is converted to AC, and the AC is given to the slip ring induction motor, in that case it will work as above synchronous speed. Here the power flow is from right to left, or from the source to the slip ring. The static Scherbius system is of two types. So first is DC link static Scherbius system. Second one is Cyclo Converter static Scherbius system. First one will get above synchronous speed and below synchronous speed. So with the power flow controller, we can achieve above synchronous speed or we can achieve the below synchronous speed. So for the cyclo converter based, as like my 3-phase supply is there and I am running the induction motor which is connected to a mechanical load and getting power from 3-phase supply, and we have that 3 slip rings from where we can recover the slip power, and these 3 different slip ring again fed back into cyclo converters. Cyclo converter is a solid state device which input is 3-phase AC and output is also 3-phase controlled AC. So the output is again given into the power supply. Here also you can see the electrical power is fed in the supply. So that mechanical power is coming back as electrical power. This is all about the cyclo converter based static Scribbler system. With this, I completed the slip power recover system. Thank you so much.